Hello my dear children. Today we will learn chapter number 9, Rational Numbers. Introduction. In this introduction video, we will understand the concepts of this chapter. Chapter number 9, Rational Numbers. Introduction. You began your study of numbers by counting objects around you. The numbers used for this purpose were called counting numbers or natural numbers. They are 1, 2, 3, 4 till infinite. By including 0 to natural numbers, we got the whole numbers. For example, 0, 1, 2, 3, 4 till infinite. The negatives of natural numbers were then put together with whole numbers to make up integers. Integers are negative number, positive number and 0. Thus extended the number system from natural numbers to whole numbers and from whole numbers to integers. We were also introduced to fractions. These are numbers of the form numerator by denominator, where the numerator is either 0 or a positive integer and the denominator a positive integer. You compared two fractions, found their equivalent form and studied all the four basic operations of addition, subtraction, multiplication and division on them. In this chapter, we shall extend the number system further. We shall introduce the concept of rational numbers along with their addition, subtraction, multiplication and division operations. What are rational numbers? The word rational arises from the term ratio. You know that a ratio like 3:2 can also be written as 3/2. Here 3 and 2 are natural numbers. A rational number is defined as a number that can be expressed in the form p by q, where p and q are integers and q not equal to 0. For example, 4 by 5 is a rational number. Here p equal to 4 and q equal to 5. Now a question will arise in your mind that is minus 3 by 4 also a rational number? Answer is yes. Minus 3 by 4 is also a rational number because p equal to minus 3 and q equal to 4 are integers. Do rational numbers include decimal numbers? Yes, a decimal number can be expressed as a fraction and therefore it is a rational number. For example, 2.5, that is 25 by 10, and 25 by 10 is a rational number. Now our next topic is numerator and denominator. In p by q, the integer p is the numerator and the integer q not equal to 0 is the denominator. Thus, in minus 3 by 7, the numerator is minus 3 and the denominator is 7. Are integers also rational numbers? Any integer can be thought of a rational number. For example, the integer minus 5 is a rational number because you can write it as minus 5 by 1. The integer 0 can also be written as 0 equal to 0 by 2 or 0 by 7, etc. Hence, it is also a rational number. Thus, rational numbers include integers and fractions. Now come to the next topic, equivalent rational numbers. A rational number can be written with different numerators and denominators. For example, by multiplying the numerator and the denominator of minus 2 by 3 by 2. Minus 2 by 3 equal to minus 2 into 2 upon 3 into 2, that is 2 2s are 4, and minus plus minus 4, 3 2s are 6. Thus, minus 2 by 3 and minus 4 by 6 are equivalent rational numbers. By multiplying the numerator and denominator of a rational number by the same non-zero integer, we obtain another rational number equivalent to the given rational number. This is exactly like obtaining equivalent fractions. Just as multiplication, the division of the numerator and denominator by the same non-zero integer, also gives equivalent rational numbers. For example, by dividing the numerator and the denominator of minus 15 by 20 by 5, we get minus 15 by 20 equal to minus 15 divided by 5 upon 20 divided by 5. So 5 3s are 15, minus 3, and 5 4s are 20. Thus, minus 15 by 20 and minus 3 by 4 are equivalent rational numbers. The next topic is positive and negative rational numbers. If the numerator and the denominator of a rational number are both positive or both negative, then the rational number is positive. For example, 3 by 5, 2 by 7, minus 12 by 19, etc. are positive rational numbers. The numerator and the denominator of a rational number have opposite signs, one positive and the other negative, then the rational number is negative. For example, minus 3 by 5, 2 by minus 7, minus 12 by 19, etc. are negative rational numbers. 0 is a rational number which is neither positive nor negative. Our next topic is rational numbers on a number line. We have learnt how to represent integers on the number line. Look at the number line given below. The points to the right of 0 are denoted by positive integers. The points to the left of 0 are denoted by minus sign and are negative integers. We know that minus 1 and 1 lie on the left and on the right of 0 respectively and are equidistant from 0. Similarly, minus 2 plus 2, minus 3 plus 3, minus 4 plus 4, etc. are pairs of numbers which are equidistant from 0 and lie on the opposite sides of 0 on the number line. We have also learnt how to represent fractions on the number line. Let us consider the fractions 1 by 2 and 3 by 2 on a number line. On a number line, points A and B represent 1 by 2 and 3 by 2 respectively. 3 by 2, that is one integer 1 by 2. It lies between 1 and 2. The negatives of 1 by 2 and 3 by 2 are minus 1 by 2 and minus 3 by 2 respectively. Just as in the case of integers, 1 and minus 1 are equidistant from 0 and lie on the opposite sides of 0. The fractions 1 by 2 and minus 1 by 2 also must be equidistant from 0 and must lie on the opposite sides of 0. In this way, rational numbers can be represented on a number line. Come to the next topic, rational numbers in standard form. A rational number is said to be in the standard form if its denominator is a positive integer and the numerator and denominator have no common factor other than 1. To reduce the rational number to its standard form, we divide its numerator and denominator by their HCF, ignoring the negative sign, if any. For example, reduce 4 by minus 6 to standard form. HCF of 4 and 6 is 2. The denominator of 4 by minus 6 is negative. Hence, we divide the numerator and the denominator of 4 by minus 6 by minus 2. Therefore, 4 by minus 6 equal to 4 divided by minus 2 and minus 6 divided by minus 2. 2 2s are 4 and minus plus minus 2. 2 3s are 6 and minus minus plus 3. Thus, minus 2 by 3 is the standard form of the rational number 4 by minus 6. Our next topic is comparison of rational numbers. To compare two negative rational numbers, we compare them ignoring their negative signs and then reverse the order. For example, let us consider minus 2 and minus 5. Ignoring the negative signs, 2 is less than 5. Now putting the negative signs and reversing the order of inequality, we get minus 2 is greater than minus 5. Observe it on the number line. On the number line, the number which is to the left is the smaller number. Thus, 2 is less than 5 and minus 2 is greater than minus 5. Come to the most important points, rational numbers between two rational numbers. We can find unlimited numbers of rational numbers between any two rational numbers. To the next topic, operations on rational numbers. Addition. While adding rational numbers with same denominators, we add the numerators keeping the denominators same. For adding two rational numbers with different denominators, we find the equivalent rational numbers of the given rational numbers with their LCM as the denominator, and then we add the two rational numbers. For example, add minus 3 by 4 and 5 by 6. Solution: LCM of 4 and 6 is 12. Therefore, minus 3 by 4 equal to minus 3 into 3 by 4 into 3. 3 3s are 9, minus plus minus 9, and 3 4s are 12. And 5 by 6 equal to 5 into 2 and 6 into 2. 5 2s are 10, 6 2s are 12. Therefore, minus 3 by 4 plus 5 by 6 equal to 9 by 12 plus 10 by 12. That is minus 9 plus 10 upon 12. That is 1 by 12. Additive inverse. For example, 3 by 4 plus minus 3 by 4. Therefore, 3 plus minus 3 by 4 plus minus minus. So, 3 minus 3 by 4, that is 0 by 4, and 0 by 4, that is 0. Therefore, 3 by 4 and minus 3 by 4 are additive inverse of each other. Similarly, minus 7 by 11 and positive 7 by 11, positive 1 by 2 and minus 1 by 2, 6 by 17 and negative 6 by 17, etc. are additive inverse of each other. Point to remember: subtraction. While subtracting two rational numbers, we add the additive inverse of the rational number that is being subtracted to the other rational number. Come to the next topic, multiplication. While multiplying a rational number by a positive integer, we multiply the numerator by the integer, keeping the denominator unchanged. Just as in the case of fractions, we multiply two rational numbers in the following way. Product of two rational numbers equal to product of their numerators by product of their denominators. For example, minus 2 by 5 into 8. Therefore, minus 2 into 8 by 5. 2 8s are 16. Minus plus minus 16 by 5. Therefore, minus 3 integer 1 by 5. Our next topic is division. Reciprocal of a rational number. We know how to write the reciprocal of a fraction. For example, reciprocal of 2 by 3 is 3 by 2. We extend the same idea to reciprocals of non-zero rational numbers. For example, reciprocal of minus 3 by 10, that is 10 by minus 3 or minus 10 by 3. The product of a rational number with its reciprocal is always 1. To divide one rational number by the other non-zero rational number, we multiply the rational number by the reciprocal of the other. For example, minus 5 by 7 divided by minus 10 by 11 equal to minus 5 by 7 into 11 by minus 10. Therefore, minus 5 into 11 by 7 into minus 10. 11 5s are 55, minus plus minus 55, and 10 7s are 70, minus plus minus 70. So 11 5s are 55 and 14 5s are 70. So 11 by 14 minus minus plus.